again this story that will be told by Rayleigh Strauss.
So, תודה. אני מתכבד להציג כאן היום, תודה רבה. Coming after Ron, I feel, and I hope you excuse me on this, Blair, a little bit like going to the Pope to talk about Catholicism, because Canadian innovation just, I mean, it's amazing what's being done here, and we can learn a lot from you. Today is very special for me to be giving the talk, and it's not just because of weather conditions, but I do want to let you know what it looked like in Toronto just 10 days ago. And this is the scene on the left is outside my house. The scene on the right is outside my office. This is not in the middle of January. This was in April, 10 days ago in Toronto. We didn't quite call in the Army for this one, Blair, but we were close. But even more so, there are many opportunities that I have to speak in many fine venues, but being here on the 60th anniversary of the Israeli Heart Society is really a unique and wonderful honor for me, and I truly want to tell you how special it is for me to be here today. I think in order to do that, I have to give you just a little bit of background, and I hope you will indulge me, and I'll try not to go over because of it. I come from a small town, or a medium-sized town in Ontario. This is the map of Canada. Israel would probably, would fit into this part in here. It's a large country, and exactly where I come from is this area. And it's a city that's called Kitchener-Waterloo. It's about 70 miles, 100 kilometers from Toronto. And there it's showing there, and you can see it relative to Toronto around the lake. And around the turn of the last century, Jews came from Poland, and a small number of them settled in Kitchener, including my family. And this is the synagogue that was initially built there around the turn of the last century. In fact, I know the family of the man standing there, who, of course, is no longer alive. But as the community prospered in our town, they built another synagogue that was much nicer, had a great gym where I used to play basketball. And amongst the features in that particular synagogue was this to the right, which are classrooms. And Ron talked about school and education in Canada. Well, we didn't get to go home at 12 o'clock. Actually, we had to go to regular school every day and finished about 4 or whatever. And then 3 times a week we were, I would probably say the word forced. It's probably pretty accurate. We were forced to go to additional Hebrew school in this particular area. And I'm quite sure that the reason that I didn't end up as a NHL hockey player is I could not play with my friends in the afternoon, but was unfortunately sentenced to go to Hebrew school 3 times a week. And inside these classrooms, we learned about Judaism and about Israel. And I had many hours to look at the walls. And on the walls were pictures like this, which were posters that came from Israel, showing beautiful scenes. This one, the stab's interesting because of the bulim that we saw yesterday done for the heart one, and some of those nice-looking girls looked like great reason to go to Israel. And on top of that, the beautiful pictures of Jerusalem. And so for many, many hours as a child, I would sit there and look at these pictures and dream what it was like to go to Israel. And finally, in 1975, I made my first trip here when I was 17 years old, and that's me, not the tall guy, with a lot more hair at that point. And at that point, I really fell in love with this country, and I've been running after it ever since. And the first time I came here actually was medical-wise was when I was a medical student. I was at Hadassah, but I returned a few years later in 1986 doing a cardiology elective when I was a resident, and that was me at the time, a little bit older. And some of my friends and colleagues at that point that I learned from, I think people can recognize a young Professor Gottesman. This one probably everyone knows, but actually my favorite was Fanny. She was way more interesting than the other ones, but I don't know what happened to Fanny, but she was very nice. So built on that, I had this very special relationship with this country that I've really tried to nurture over the years. And I'm very proud of there's actually I think 8 or 9 fellows that we've done now. I've had pictures here of 7 of them. You can see some of this. I think everyone in this room knows some of these people. Meets right at the front. You can see in the part, these are the Tel Aviv area guys, and these are a little bit north of Tel Aviv, and these are the Haifa ones. And I know there's problems in Israel from where you come from. So even I put Sergey between the two Carmel guys just to show this Rambam Carmel collaboration there that hopefully is very strong. So for me, it's been extremely important to be part of what Israel. I've, in my own small way, tried to do what I can for the country. And so to be here today to speak on this particular topic is particularly meaningful, and I just want to thank you for it. So what I'm going to talk about is a tale of a Canadian innovation. And opposed to what Amit said, it is a crazy idea started, but it's not a phase 2, it's a phase 3 study. I just have to make up front my disclosure that I have a company formed around it called Matrozyme and IP about it. And I've been interested in innovations, probably based on the work I've done with Israelis over the years. And this was one of my first ones, which was trying to improve really the culture of the cath lab. The Israelis never seem to take it on. And I like this, but because I thought, if you're using really high-priced equipment and very finely engineered equipment, you really should dress the part as well. But somehow it just didn't catch on, and probably didn't catch on because I didn't know exactly the rules of innovation at that time, which I think I understand much better now. And I've learned that this whole process of innovation can be extremely addictive. So what I would like to go through here during my talk is the 10-step program that I've tried to follow in order to try and control this addiction. And the first is to establish the clinical need. The second is to know that there's a market size that's going to be able to support what you're going to do. The third is whether or not it's patentable. The fourth is you have to do preclinical work to actually show what you're doing works. 5 is manufacturing, that you can actually produce the material that you're looking for, whether it's a device or some type of biologic, which I've been working with. 6, the challenge of early financing, which Ryan alluded to, can be extremely challenging, and particularly in Canada. I think that's the case. The regulatory issues, which are substantial and continue to give me a certain amount of grief at times. The start of a first-in-man, which I think is a critical milestone. Finally, once you get through the first-in-man, you really have to have later financing, and this becomes at times an even greater challenge to do. And finally, that idea of that pivotal trial that you have to do in order to move it forward to the final step. And I'm going to be talking here about chronic total occlusions that probably most people in the room are aware what they are, but in case you're not, this is a right coronary artery that's occluded the catheter, and you can see that the artery should be coming distally, but it's occluded right there. And we know that these arteries are occluded probably for at least 12 weeks or longer, that they TIMI 0-1 flow. And when you correctly select the patients for revascularization, you can improve angina, improve left ventricular function, and probably, or perhaps, I cannot say probably at this point, you may even affect mortality. So there are reasons to do it in selected patients, but I want to state up front that this is really not a therapy to use on every patient with a CTO. So let's go through a little bit of the list of my 10-step program. Is there a clinical need? Well, most studies show that there's only a 70% success rate in selected cases treated with PCI with conventional techniques. And the majority of the time, these failures, or more than 90%, probably 95% or more, or 99%, are inability to cross with guide wires. And for those who really attempt them, and I'm not sure if these are as hot areas as in Canada, in Israel, but these can be very difficult and inefficient procedures, which are very long. They take a lot of fluoroscopy time and heavy contrast use. And at the end of a very long period of time, you may actually be unsuccessful. So you have the frustration of failing in addition to taking up your cath lab half the day. So the next point, is there really a sufficient market size to warrant a new therapy? We have done a very interesting study in Canada. It was published about a year ago in JACC. The first author is Paul Pfeffer, who works here at Teleshomer with Amit. Worked with me for a few years. You can see also Sergey Yalenetsky, who's contributed to this paper as well. And what we did is we looked at 3 very busy cath labs in Canada, 2 in Toronto, 1 in Calgary. We looked at all the patients that came for coronary angiography to see how many of them had chronic total occlusions. And what we really showed here that I think was extremely important is that over 15,000 patients that came for heart catheterization, that overall, if you exclude the ones that really have normal coronary arteries and are being cathed for either diagnostic reasons for atypical chest pain or for valve, that about 20%, so 1 in 5 patients that come to the cath lab has a chronic total occlusion. So that's a lot of patients, 1 in 5 patients. And in fact, you will say, well, aren't those all patients who've had big infarcts and have occluded arteries. In fact, 50% of them have normal LV function, and about 30% have very mild impairment of LV function. So over 80% of these have LV that is clearly viable. And when you take those numbers into the U.S. number of angiograms, 3.6 million, this works out to over 500,000 CTOs in the U.S. a year, and probably at least twice that worldwide. Not only that, but there's great variability within the sites, and this is just showing the CTO site, or the cath lab sites in Canada in the study, and you can see the difference between where one site, only 1% of all CTOs were treated by angioplasty, and in another site, 16%. So there's a huge variability between sites depending on the talent of the operators and the interest in that particular site. So I think that there's huge opportunities to try and improve the rates, particularly once it becomes easier to do. If you take 100 CTOs, you would find that 65, so 2/3 of them are only treated medically. No attempt is ever made at revascularization. Bypass accounts for 25% of the therapy, and PCI is actually less than 10%. So more than 90% of patients are not being treated by PCI, and in fact, only 30% of CTOs are revascularized, despite the fact that over 80% have really near normal LV function. So the next step is trying to decide what is the therapy you want to do, and this is what I've done is collagen is the target that I'm working at, based on work that I've done experimentally and, of course, some of the human pathology data. And it's a very important CTO target since it's the main extracellular matrix protein that's found within the chronic total occlusion, and it increases with age. And our invention that we've been developing over the last few years is bacterial collagenase. So this is an enzyme that is produced by a bacteria that actually targets collagen. And the time that I started this, you can see how long it takes, is April of 2000, when I started off with a $10,000 grant from St. Michael's Hospital research competition, and now that's grown into basically a $10 million company at the present time. So bacterial collagenase is an enzyme that's available as 2 isoforms and a small amount of additional proteases. It's a biologic, so it has special properties. And you take a bacteria, which is Clostridium histolyticum, you put it in a medium where it makes a soup of enzymes, which include collagenase, and then you isolate the enzyme. And 10 years of preclinical work basically showed that we can initiate collagen degradation and optimize its activity without damaging the deeper vessel wall structures. And this is a sort of picture to show how we do it. We have a microcatheter that we're using now. We embed it into the proximal part of the chronic total occlusion, inject the collagenase into the proximal fibrous cap of the occlusion. We give it a period of time to work its way and soften it, and then we come back the next day and try and cross it. Now, there are many potential indications for looking at collagenase and CTOs, and the one that we're really starting with is looking at those that have failed using standard therapy or standard attempts. But there are other ways. There's the 65% treated medically, some which really need to have some therapy done to improve patients. A large number of patients with CABG are only sent for CABG because of the inability to revascularize by PCI, and as well it may also increase the speed. So there's a whole number of ways that we can increase it, and what we hope is that we can increase PCI instead of being less than 10%, that we would have maybe 20 to 30% of the patients would be treated by PCI. And that creates quite a large potential market size, which is very important when you try and attract investors into the therapy. You have to show that there is a financial incentive for them to become involved. And just looking at the various types of indications here, you can see whether you look at the U.S. market or the worldwide market, not maybe huge numbers compared to pharma, but certainly reasonable numbers that will appeal to investors. The next point is your therapy patentable? And I've shown here actually 2 of the U.S. patents that we've had on collagenase. These have taken many years to go through several different types of actions. In fact, when you look at the cost of just doing the patents, basically in the U.S. it works out to about $100,000 and about $100,000 outside U.S. So patent costs cannot be underestimated, and they can be a battle. Now, the proof of concept was done in preclinical studies that started in 2009. This was Amit was there at the time with me, and this was a paper that we published in Circulation, and another paper that Amit was first author on a couple of years later, looking in rabbit models of chronic total occlusions. And we were able to show that when you inject the collagenase into a chronic total occlusion model that we created in the femoral arteries of rabbits, and we had to actually develop this model. There was no pre-existing model, so it took us a couple of years to really perfect it, to show that it had many of the features of patient CTOs. And we were able to show, and this is from the circulation paper, that in a blinded study, that if you injected 2 different doses of collagenase versus placebo, you had a significant improvement in guide wire crossing rates. And that was the basis of the work at that early stage. Initially, when we started working with collagenase, we actually just took it off a bottle on the shelf that we're using for digesting tissue for doing cell culture. But obviously, you cannot just take that stuff off the shelf and just inject it into patients, so you have to manufacture GMP collagenase. And interestingly enough, given the wonderful relationship I've had with Israel over the years, and this was not on purpose, but the company that I was working with in the United States made an agreement with me to manufacture the GMP collagenase at a manufacturing facility that's only about 2 miles from where I'm, probably even closer, a mile away from here, at a Jerusalem facility. A wonderful facility. In fact, we were one of the first GMP products that actually were done in this brand new facility, and it's another wonderful link between myself and Israel on this project. Now, early financing was a challenge, and fortunately I was able, with some repeated attempts, to get grant support from the Heart and Stroke Foundation of Canada, as well as the Canadian Institute of Health Research. I put in a fair amount of the funds, as well as family members, and initially, actually, at one point, I was looking at incubators here in Israel to do some of the help us with some of the funding. Fortunately, we didn't ultimately need them because we had grant support. But I think that the structures in Israel for supporting this early stage inventions is extremely important, and something in Canada that I wish we had to a much greater deal than we do. So this brings me next to regulatory, and this is, I like taking pictures, you can see, and this was the first visit to the FDA in November of 2010, and kind of one of those things in life that you always hear about everyone going to the FDA. I'm going to the FDA, and it sounds like such a cool thing to go visit, and I was kind of excited about it. It was all these very intense ID checks, and you felt you were really going to, even more than going to see the president yesterday here. When you go to the FDA, it's a pretty intense experience. We're going through the security first and meeting a room full of experts there who can be very challenging and continue to be very challenging, but I think always with the best interests of patients at heart. So we continue to discuss things with the FDA and Health Canada. So it brings me to the first in man. This was a real labor of love. We had to have regulatory support from Health Canada. This started in January of 2008, so this is over 5 years ago when I went for my first visit. Of course, I needed support from my research ethics at Sunnybrook Hospital. They had to be convinced to use a totally new therapy in patients. And, of course, conflict of interest. I had to be very careful to have a number of things in place to do it. So we finished that trial, first in man, and this is published in Circulation again about a year ago, and I think the results were excellent. They're really just a safety and feasibility trial. Was done in 2 Toronto centers. Sunnybrook and St. Mike's was 20 patients, but in fact we did an additional 8 patients to look for PKA studies. All the patients in the study had previously failed, so they were all failures, so they had really no other options, at least we felt they didn't. And it was a dose escalation study. We had 4 increasing dose cohorts, 5 patients per dose, and we went up to 1,200 micrograms, starting at a low dose because we wanted to make sure it was very safe. We injected initially through an over-the-wire balloon, and later we used a microcatheter, and the PCI was done the next day, so the patients were kept overnight. And these were the 2 different ways that we did it. When initially injected through an over-the-wire balloon that was inflated, but later we found it much better to inject directly into the CTO. And this was one of the research nurses preparing it. Most of the lesions were in the LED. They were at least over a year old, the median, and were quite challenging. And the results were very good. It was very safe. We had very few problems with it. And we're able, in the 28 patients, to have 75% success rate in previous failures, which we thought was pretty good for a new therapy, especially when you're looking at even low doses, which may not be as effective when you're starting. And not only were pretty good results, but we were able to cross with really soft guide wires. And for people who, interventionalists who do this, there is a reluctance to use very stiff, hard guide wires because you may damage the wall and perforate. But the ability here was to, in at least 80% of the cases, we were able to either cross all of it or almost to the end of it with a very soft guide wire, and occasionally we needed a stiffer one at the end. So we had very nice results, very few complications mainly related to some side branch occlusions, and the patients did extremely well in the follow-up CT angiograms, and in one case the cast showed everything was very good. I'll just show you a brief case history. A 50-year-old man with inferior wall ischemia, and just to show you a little bit about what this therapy can do. This is a cornea angiogram showing the left corneal artery. You can see here the right filling from collaterals. This is the right. And I want to show you that this is ending right here. This is the end of the occlusion. There's a little branch here. And this proved to be an extremely difficult one to inject. And the reason is that the wire would always go down that little side branch. And only when I was able to, this is the type of equipment we had to have there for injecting. I had a guide liner, I advanced a Confianza Pro 12 guide wire, as well as an Amplatz guiding catheter to be able to insert the Confianza Pro guide wire about 1 or 2 millimeters into the occlusion, because it was so tight and so hard I couldn't even push it in 1 or 2 millimeters. Able finally, with all of that support, to inject. And the next day we came around. This is just showing where the occlusion, where the end of the microcatheter was. And I was really, I had great doubts of how it would be the next day. So this is what it looked like before we actually started to do the angioplasty. You can see it really doesn't look much different. There's no occlusion. This is that side branch right before the end of the occlusion. And within about two minutes or right at the beginning, you can see with a Pilot 50 guide wire, which is a very soft guide wire, we already had advanced almost near the end of it. We're a little bit off actually at the distal part. And within 4 minutes, we had actually crossed into the occlusion with a soft guide wire. We had to wire the lower branch here to make sure that we're into luminal all the way. And finally, in this case, we put stents and had a wonderful result. And clearly, there was no way this could have been done anterograde without the collagenase. And I'm almost over time, so just give me 1 minute, I'll be done, okay? This is the first-in-man financing. We had to have a management team and a home. We've raised about $9.6 million now, all through private investors. No VCs are involved, and this is our very modest place. You can see even the name of the company is very small writing at the bottom of this place in North Toronto. We have a very small but talented team of people working with me, and now we're planning this CTO2 clinical trial of 30 to 40 sites in Canada and the United States, and hopefully we'll get started in the third quarter of 2013. The principal investigator is Chris Buller. This is the IND that we've submitted. We still have to answer some questions from FDA before we approval to start, but we're getting there. And as my last part, I just want to leave you with one final message, and that's the toughest battle is really you have to persevere despite obstacles. I think that's what you call chutzpah here. Ron, I think that's what you meant. And for instance, this was a report when we did the first in man at the Euro PCR in 2011. Just says that we had this novel enzymatic technique to improve it. And then you have, this was from one of the people on the committee that was reviewing at the time in the audience. They say, I must say I'm a little skeptical, but I don't understand the way it works. You constantly have to face a lot of skepticism, which is, I think, reasonable, but you have to really have a lot of confidence in yourself and what you're doing to go this long road. And this is something from Tehillim I think people here will have heard before. And I just, for those who don't read Hebrew, this is the stone which the builders rejected has become the chief cornerstone. And the idea here is, even though people may ridicule what you're doing, eventually, if you persevere and believe it, I think you can accomplish great things. And since my brother's a reggae singer, in his honor, I give, this is the song that has been developed for that. So thank you very much for your attention.